And once again, we're back from commercial. And if you haven't figured it out already, now is the time to turn your page to the second page. And at the top, we have example 2, evaluating a numerical expression. So what we're going to do here is we're going to use this difference of squares pattern to make it easier to do some arithmetic. So we have 54 squared minus 48 squared, which could be written as 54 plus 48 times 54 minus 48. And that means that 54 and 48 together, that is 90 plus 12, which is 102. And we have 54 minus 48, which is 6. And so what we're really going to do is multiply 102 times 6. So I think you might be able to see that pretty easily as 6 times 100, which is 600, plus 6 times 2, which is 12. So 612 would be the total. So just using this pattern to help us do some arithmetic. On this other example, we have 68 squared minus 62 squared. So that difference of squares could be written as 68 plus 62 times 68 minus 62. And let's see, 60 plus 60 is 120, and 8 plus 2 is 10, so that's going to be 130. I hope you can see that okay, that's 68 plus 62, 120 plus 10. Okay, and we're going to multiply that by 68 minus 62. Hopefully you can do 8 minus 2 to get 6 for that. And for this one we might want to think about 6 times 100, which would be 600, plus 6 times 30, which would be 180, and then that sum is going to be 780. So again, I'm going to pause your sub. We'll pause the tape for a moment, the video, and give you a few minutes to do number 5 and number 6. All right, and we're back. And this one you should have written as 36 plus 34, and 36 minus 34, and 36 plus 34 is 30 plus 30 plus 10, which is 70, and 36 minus 34 is 2. 70 times 2, 140. And over here on number 6, we could have written that as 55 plus 50 times 55 minus 50. This looks like 55 plus 50 is 5 more than 100, which is 105. And 55 minus 50 is 5. So this is going to be 5 times 100, which is 500, plus 5 times 5, which is 25, and that total is 525. All right, now we're going to look at another special pattern, and we've talked about this before as well. We're going to talk about it in general terms with these notes in the middle of the page, and we're going to think about what would happen if we're multiplying the same thing. In other words, we're squaring a binomial. So we're doing a plus b times a plus b. So what happens when we do that? We're going to get a squared there. We're going to get a times b in this box. We're going to get a times b in this box. And in the last box, we're going to get b squared. So what happens in these cases when you're squaring a binomial, and we have talked about this before, is that the items in these two boxes are always identical. So there's always two of whatever those are. So that's why over here on the pattern, it shows that when you multiply these two binomials, you're going to get a squared right here. You're going to get b squared at the end. And in the middle, you're going to have two of whatever these were. Well, these were ab. So we're going to have 2ab in the middle. Now, this can work whether you're squaring a binomial that is something plus something, or squaring a binomial that is something minus something. Works either way. So let's quickly look at, I don't like this little thing here, but let's look at what would happen if we did, let's use a minus this time. Let's do x minus 3 and x minus 3. So in this concrete case, this will be x squared. Over here we have negative 3x, multiplying those two things, then multiplying negative 3 times x, we get that same thing again. And in the final box, we have negative 3 times negative 3, which is positive 9. Again, notice that instead of opposites, now these are identical. Okay, we're not multiplying conjugates, we're squaring a binomial. So the factors were identical, and that means these two boxes are going to be identical. So there's going to be two of whatever that is. All right, so let's try applying that in a way that we can use for factoring. So in this case, well, one thing is, in order to apply this, we need to recognize if this is a square number or not. So 16 is a square number. It's 4 squared. And then we should check to see if 4 doubled gives us the middle term, which in this case it does. Okay, so we can quickly write this as n plus 4 squared. Okay, because we know that if we did a box, we would get 4n and 4n in those corner places. 16 would be in the lower corner, n squared would be in the upper corner, but these two would both be 4n's. Okay, and so that's how we know that it's going to end up like this. So square root of that and half of this. Okay, we also have to take the square root of the leading term. So I'll show you what happens on that over here on B. So we will have, this is a square number, this is a square number, and that is 2. This is actually 2x squared, and this is 3 squared. But if we would take this times this, the 2x times 3, and double it, then we would get 12. And because this is a minus, then we would have minus in the middle here of our binomial. So we can say 2x minus 3 squared is the factorization of this trinomial. Okay, so once again, the square of this is there, the square of this is there, and this times this doubled is there. That's how that shortcut works. Now, I should say that you do not have to take that shortcut. We could fall back on our normal strategy, the box, or either the box or using the grouping method that we talked about last time. We could have 9 and 4x squared here. Now this is 36, and we would want something we can multiply to make 36 that also gives us negative 12, and that would be minus 6 and minus 6. Okay, that sum is negative 12. And then we would figure out that we couldn't have 4 here, we would have to have 2. Couldn't have 4 here, that would have to be 2, this would have to be 3, this would have to be 3. So you could do it that way too. All right, so looking at example C over here, we're going to have, looks like this is 13 squared, and it looks like this is 2 times 13 in the middle there. So it looks like we can say x plus 13 squared. Okay. One more over here before you guys get a try. This is 3 squared. This is 4 squared. 4 times 3 twice is the middle. So I'm going to say 3x minus 4, because this is a minus 24, squared. Okay, so 3 times itself is 9, 4 times itself is 16, 3 times 4 doubled is 24. All right, it's time for you guys to make a try at number 7, 8, and 9. And I'll pick you up on the next video and show you how you should have done those.